How?
Output level and then you change
Yes.
the knob.
Change the knob.
Knob, yeah.
Type of the output. Type.
The frequency?
No, I want square wave. I want triangular waveform. I want.
Oh, it's right there.
Wait.
The one in the bottom, waveforms.
This thing here.
Yes, sir.
That's right.
Yeah, boy.
Yeah, boy.
Okay, so here, square wave, sine wave. One more time, it'll give you triangular waveform. The type of output waveform. How to change the output frequency.
That one is.
There we go. And how do I change it to, say, 100 kilohertz? Okay, 200 kilohertz range. And then turn the knob to 100 kilohertz. Now, you're on the fine adjust. No, you're on the fine adjust. See the button down there?
Which button down there?
It says fine adjust.
Oh, this one?
Yeah, disable the fine adjust, and now you can just jump to 100 kilohertz.
How do I jump? I don't understand.
Just turn.
Oh.
Yeah. You were on fine adjust, and now? Okay, fine adjust down to 100.
So would it go down? Oh.
Yep.
That's something I didn't know
Okay, all right.
about. Wow, why am I the only one doing this, guys?
That's excellent.
Because you're the best.
Because yours are
Bro, you need to learn too.
No, man.
Okay.
You teach us.
So is that okay so far?
Two down.
Bro, I did two, you did
Is that
two.
okay? How to change the output voltage?
Output voltage.
It's right there.
It's under output level.
Output level.
Yes.
Okay, turn it down to output level, and turn it to, let's say, 5 volts peak to peak. How's that?
5 volts?
Peak to peak.
Peak to peak.
Oh, okay.
So that's
Okay. All right. Now, this may be 5 volts peak to peak. I don't know. The reason why I say I don't know is because I do not trust this display. This display can be grossly inaccurate, and that's why I never trust this display. It might show me 5 volts peak to peak. So I'm going to verify that with my oscilloscope. All right, so this is my oscilloscope, and maybe I'll just use the ×1 setting, a little bit simpler. And before I use the scope, I have to make sure the scope is working fine. If the scope is not working fine, I don't even use it. I switch station, all right, because the scope is not even working. So you have to find out if the scope is working first. So I'm going to use the calibration signal.
Well, I was trying to do that and it kept falling out.
Oh, yeah, but you gotta hold it.
Oh.
Okay, so how many volts are you expecting to get from here? How many volts? What?
600
600 millivolts. And what frequency are you supposed to get from here?
-2.
Sine wave, sine.
Okay, so how come this is so fuzzy?
You got to
Can't
adjust
see
it.
anything.
Adjust it.
Focus. All right, so I'm gonna focus it in.
And then auto
All right,
auto
so
set.
now we're all set. Auto set, your best friend. Auto set. And now this is roughly 1, 2, 3. Fine. About 3 blocks at 0.2 volts per block. Right? 3 divisions. 3 major divisions at 0.2 volts per division. So roughly 0.6 volts, which agrees with this number here. Right?
Wait, what? How did you measure that?
From here to roughly here, I get 1 division. From here to here, I get about 1 division. From here to here, I get another division. So 3 divisions times 0.2 volts per division,
Isn't it 3.6?
about 0.6.
3.6.
No, 0.2 volts per division, and I get roughly 3 divisions from peak
Oh,
to
okay,
peak.
okay.
3 times 0.2 gives me about 0.6. So I get about 0.6 volts from peak to peak, so that agrees with the number here. So the probe is okay, the scope is okay. All right? So now I can use the probe, I can use the scope to measure this voltage, this signal here, and this signal I can ground, I can connect the grounds together first. But normally it doesn't matter, but if you have the ground wires here, why not? Black to black. And someone just made a dire mistake over there. He connected this
That's reversing
signal to ground. Is that okay?
No, that would reverse it.
signal to, well, yeah, but you're grounding your signal.
Yeah.
This is your voltage, you're grounding it. Of course, you're not going to get anything. So you connect all the grounds together, make this ground, black, 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 okay? So you connect the grounds together, all the ground alligator clips together. This is going to give you the supposedly 5 volt peak-to-peak signal, a sine wave. And here I want to measure this signal to see if I'm getting 5 volts peak-to-peak. Okay, so now the tip goes to the alligator clip. And now I'm supposed to get 5 volts peak-to-peak, and I don't see anything. What am I going to do?
Auto start.
Auto set. Okay, so auto set. So now I see a small signal like that, so I'm going to just increase the size of the signal. I'm not increasing the voltage, but I'm just increasing the display. Again, any button, any knob I turn and push in here, I'm not going to be able to change the voltage. The voltage comes from here. When I do anything here, I won't be able to change the output from here. I won't. So I'm just changing the display, magnify it, and string it so that I can measure more accurately. So now the voltage is the highest I can display on the screen, because if I just do one more, I'm not going to be able to see the top and the bottom. So I got to go back down one notch. And now I have to measure the voltage between the peak and the peak to give me the peak to peak. The voltage sensitivity setting right now is 1 volt per division. And how many divisions do I have from peak to peak? Roughly.
3.
5.
Roughly 5.
Oh, sorry, peak to peak.
So from here, 1, 2, 3, 4, 5, roughly. Okay. So I'm okay, kind of, but I got to be more accurate. So I'm going to use markers now. So I push it one time, and now I'm going to just change the mode from both horizontal markers and vertical markers to only vertical markers. So with only vertical markers, I'm going to turn the markers, both markers, to mark the bottom peak first, and then turn this knob. Before I was turning this, now I'm turning the top marker to mark the top. All right, bottom, top. And now I'm getting about 5.24, which is kind of far off. So I'm going to turn this guy down to 5.00, or very close to 5. So I'll turn it down a little bit, and now track it again. Track it again. Right. So I get about 5.03. Right. So I guess it's good enough. 5.03, or maybe 5.0. Yeah, 5.06. I think it's good enough, because if you turn even one notch down, you're going to get even farther away than 5.06. So you're going to get only like 4.91, 4.90. That's too far off. So I'm going to settle with this, which is 4.8 here. And now I turn the bottom marker and the top marker to give me very close to 5 volts. All right? Good? Okay. So how to change the output voltage? That's how I'm going to get 5 volts. You don't trust this? Trust this. All right? How about how to change the DC offset voltage? DC offset. DC offset. And if you want to monitor the DC offset voltage here, you have to use the DC coupling. DC coupling here, right? It's DC coupling. So if I want to change the DC offset, I can move the voltage up or down. Because do you know where ground is? How do you find out where the ground level is?
Press the ground button.
Press the ground button, and you're going to be able to see the ground level here, which is right in the middle. If this is not right in the middle, you can kind of turn it to the middle here, right? So now I unground it to see the real voltage. So if I want to change my DC offset here, sorry, DC offset up and down, up and down, up and down like that, right? Now I'm moving the whole voltage up or down, meaning that if I move it all the way up, now this voltage is no longer an AC voltage. Am I correct? Ground is over here. The voltage lies entirely in the positive region, so it's not an AC anymore. Or if I turn it down here, again, it's not an AC voltage anymore. It's a DC voltage. Am I correct? Okay. Because it's always below ground, no matter how what at what time you're measuring the signal is still below ground. So that's why if you want to use a proper signal, you should make sure the DC offset is at 0. DC offset. So make sure that is at 0 before you take any measurement. And but if you are using AC coupling, you're not going to be able to see any kind of DC offset, because AC coupling, you're not measuring the true voltage. You're just measuring the peak-to-peak voltage.
So we always have to make sure that the DC offset is
Yeah,
0.
make sure the DC offset is 0, so you can measure the true voltage, whether you're using AC coupling or DC coupling. Right? So, DC offset, how to change the duty cycle.
Everything's over here.
Well, yeah, almost everything's over here. So duty cycle, make sure you have the 50% duty cycle. So if you look at the wave, well, I mean, if you have, say, a low duty cycle, you're going to get the waveform tilted on one side. Or if you see a duty cycle greater than 50%, you're going to see the waveform tilted to the other side. Okay? So it's not really a true or proper sine wave. Okay? So you should put the duty cycle to how many percent? 50%. Okay? So now this is a proper, nice looking sine wave. All right, probe calibration, I guess I've done that. So no one want me to go over that again. Ground button, you know where that is. The trace movement in the XY direction, if I want to move the whole trace this way and that way, which knob do you turn?
X and Y.
Yeah, X and Y. Here's the X position, here's the Y position. X position, right? Y position. Right? Okay. Trace illumination and focus knobs. Trace illumination, right? Trace illumination, trace intensity. Right? If you don't see anything, then brighten it. Right? It's too bright, you're going to burn out the screen, so this is kind of okay. Right? And voltage sensitivity adjustment, you can use these two buttons, right, to turn the voltage sensitivity to lower, to higher voltage sensitivity to lower voltage sensitivity. Right? So that's you resize the voltage. But you're getting exactly the same voltage, just that the voltage looks smaller or bigger. Time base. These two buttons. Right? So if you want to measure the frequency, you have to make sure that you adjust the waveform, X position, and also with the time base. I'm going to see one complete cycle.
What's the time base one?
The time base is right here. Main time base, MTB.
Oh,
And now if the waveform isn't touching, it doesn't go through the zero axis, the x-axis, then you use the level main time base to make sure it cuts through the x-axis. All right, and then you use the X position to move it over here. So now you get roughly 10 divisions, not exactly. You're missing about one minor division, but roughly 10 divisions. And if you
counted?
Well, yeah, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So roughly one cycle. This cycle goes through about 10 divisions. Each division, 1 microsecond. So the period of the waveform is 10 blocks times 1 microsecond per block, which is 10 microseconds. So the frequency is roughly 100 kilohertz, right? So if you take the reciprocal of 100 kilohertz, you're going to get about 10 microseconds. Now, channel 1, channel 2 input, this input and that input, and you can choose either one now. We're not using both at the same time in this course, so you can just either use channel 1 or channel 2. But make sure it shows channel 1 when you're using channel 1. Make sure it shows channel 2 when you're using channel 2. So when you're using channel 2, you can turn it on, turn that off, and now you're using channel 2. See? Channel 2. Turn it off, turn it on, and now you'll be using channel 2. Okay, measure by using major and minor divisions. I just showed you that. So see here, if I now want to disable the cursors, I want to count from here to here. Exactly how many divisions do we have? Not really 10. Not really 10. See, every major division has 5 minor divisions, right? From here to here, from here to here, we got 5 minor divisions. 1, 2, 3, 4, 5. Right? Right? So one major division now has
5.
1 microsecond. No, 1 microsecond.
Microsecond, okay.
1 microsecond. 1 major division. So 1 minor division gives us 0.2 microseconds. Right? Divided by 5. 0.2 microseconds. And this waveform now goes through about 9 major divisions and 1, 2, 3, 4, 4.5. 4.5 minor divisions. So 4.5 times 0.2 is about 0.95. 0.95. So here, 0.95. So we got 9.95 microseconds. The whole thing is 9 up to here and 0.95. So 9.95 microseconds. If you don't want to count, you can do the horizontal
Or status.
Oops, shoot. You can do the horizontal markers. Mark the beginning of the period. Mark the end of the period. Right? And you're going to get about 9.92. Right? You can mark the end, mark the ends of this waveform, and you're going to get the delta t, which is the period of the waveform.
You don't have to count it.
You don't have to count anymore. Use markers. Voltage, you can use markers. Period, you can use markers. All right. So AC coupling, DC coupling, I've showed you that here. AC coupling, DC coupling. That's it.
So I pass if we know the stuff.
You basically pass at least 50%. At least 50%. All right.
Thank you,
No,
sir.
it's you're welcome. Any other points you want to
Yeah,
ask me?
grab 8, please.
What time is it?
It's early.
10:13.
Okay.